In this video, we're going to do a couple of harder circles problems. All of these involve arcs and angles. They don't involve segment lines. So I would recommend that you do pause the video, you draw the diagram on a separate piece of paper, you take a really long time to think about the question and try it yourself, and then you unpause the video to see how to do it, or if you get stuck, to see how to complete it, and to check your work if you do make it to the end of the questions and you want to see if your answers are correct. Chords A, B, and CD intersect at E in circle O as shown in the diagram below. Secant FDA and tangent FB are drawn to circle O from external point F, and chord AC is drawn. The measurement of arc DA is 56 degrees. The measurement of arc DB is 112 degrees. And the ratio of arc AC to arc CB is 3:1. So AC can be represented as 3x, and CB can be represented as 1x. Now, before I even continue the question, I don't like having all of these x's, so I want to find out what the measurements of those arcs are. And I see that if I add up all the arcs, I get the total way around the circle, which is 360 degrees. So I can start off by making an equation that says 56 plus 112 plus 3x plus 1x equals 360 degrees. And if I combine my like terms really quickly, I have 56 plus 112, that's 168, plus 4x is equal to 360. 360 minus 168 is 192. And then if I divide by 4, I get x is 48. So instead of writing 1x over here, I can write 48 degrees. And then if I multiply that by 3, instead of writing 3x over here, I can write 3 times 48, which is 144 degrees. And then that just looks a little bit nicer without having all those algebraic things there. It's going to help me answer questions later on as well. Determine the measurement of angle CEB. So angle CEB is this angle right over here. It is a vertical angle formed by these two intersecting chords. So what I'm going to think of is my theorem for finding the angles or arcs formed by intersecting chords, so angles inside the circle. And for angles inside the circle, I'm just going to label this as part 1 so I can question 1 so I can keep my work organized. My theorem is that the vertical angle, so the angle inside the circle, is equal to half the sum of the intercepted arcs. So I'm looking for the vertical angle, that's x, and it's equal to half of the intercepted arcs, which are 56 and 48. So now if I put that into my calculator, I do 56 plus 48, that's 104, and I half that, I get 52 degrees. So this vertical angle along with its other vertical angle are both 52 degrees. From here, I can move on to the next part of the question, which is to determine the measurement of angle F. And angle F is an outside angle. So I'm going to have to think about my theorems for outside angles. And I know that the outside angle, instead of being half the sum of the intercepted arcs, is half the difference of the intercepted arcs. And we want to do the bigger arc minus the small arc so we don't end up with a negative arc, because that doesn't make a negative angle measurement, because that doesn't make sense. So angle F is the outside angle that we're looking for, and it's equal to half of, let's figure out what the intercepted arcs are. I'm just going to highlight the rays of the angle, and I'm going to look for the arcs within those rays. And one of them is DB. And the other one that the endpoints are touching is AB. So here, I'm going to do half of, I need to figure out what the big arc is because I don't have from A all the way to B. I'm going to have to add my two pieces, the 144 and the 48. And if I do that in my calculator, I get 192. So half of 192 minus the small intercepted arc is 112. So I have 192 minus 112. That's 80. And if I have that, I get 40. So the measurement of angle F is 40 degrees. And then finally, the measurement of angle DAC. The measurement of angle DAC, that's this angle right over here. So I'm just going to highlight that angle. And notice how it's an inscribed angle. And it intercepts arc DC. So inscribed angles are half their intercepted arcs. So I just need arc DC and then to take half of that. So arc DC would be 112 plus 48, which is 160. And then if I take half of 160, because inscribed angles are half of their intercepted arcs, I get 80. So that would be 80 degrees. That one didn't require that much work, now that we did the other ones. For the next one, I recommend doing the same thing. Draw the picture, read the question. Now that we did one of them, try your best to make it to the end. And whenever you get stuck, or if you want to check your work, if you got answers but you're not sure if they're right, then definitely unpause the video so that we can go through it together on the video. In the accompanying figure, triangle ABC is inscribed in circle O. Segment BT bisects angle CBA. So where's angle CBA? This is angle CBA, so it's being bisected. Let me make that a little nicer. So that means it's being split into two equal parts. I'm going to mark that in my diagram. TA is tangent to circle O, and the measurement of angle BAC, the ratio of the measurement of angle BAC to the measurement of angle CBA to the measurement of angle ACB. So all three angles inside the triangle is 2 to 3 to 4. Let me represent this algebraically. So angle BAC is the 2 part of the ratio. So I'm going to represent that as 2x. Angle CBA is the 3 part of the ratio. So I'm going to represent the whole angle as 3x. And then angle ACB is the 4 part of the ratio. So I'm going to represent that as 4x. And I don't like all those x's, but I do know that all three angles of a triangle do add up to 180 degrees. So I'm going to make an equation that says 3x plus 2x plus 4x equals to 180 degrees. So here I have 9x is equal to 180 degrees. So x is equal to 20. So now I'm just going to plug in and replace with actual numbers. So 2 times 20 is 40 degrees. 20 times 4 is 80 degrees. And 20 times 3 is 60 degrees. And since this angle is bisected, that means that each piece is 30 degrees. Looks a lot better. Just double check. All three angles should add up to 180. And they do. Now let's move on to what the question's asking. First, it's asking us to find the measurement of angle BAC. Oh, we did that already. That was 40 degrees. Now it's asking us to find the measurement of arc BC. So this is arc BC. And arc BC is intercepted by angle BAC that it asked us to find before, which is an inscribed angle. And remember, inscribed angles are half of their intercepted arc, so the arc is double the angle. So if the inscribed angle is 40, then the arc that intercepts it would be 80 degrees. Now the question is asking us to find the measurement of angle CPT. So it's asking us to find basically these vertical angles because they're both the same. And they're formed by intersecting chords AC and BP. And remember, the angles formed by intercepted chords are equal to half the sum of the intercepted arcs. The thing is, we don't have the intercepted arcs, because for those vertical angles, arc BA is one of the intercepted arcs, And this arc over here is the other intercepted arc, the two in pink. We don't have those. So let's see if we can find them. We did find this 80-degree angle before. And that does intercept arc BA. So if the inscribed angle is 80, then the intercepted arc is 160. So far, so good. Now we just need to find the other arc. And I think we can, because we know that this is 30 degrees and it's an inscribed angle. And it does intercept that arc. So the inscribed angle is 30, so that means the arc would be double it, which is 60. So we can write down over here the angle, the vertical angle, if you want to write that down, is equal to half the sum of the intercepted arcs. So the vertical angle, which is angle CPT, is equal to half of the 160-degree arc plus the 60-degree arc. And if I use my calculator for that, 160 plus 60 is 220, and half of that is 110. So angle CPT is 110 degrees. I'm going to put that right here in my diagram as well. Now I need the measurement of angle PAT. So PAT is this angle here. It has its vertex on the circle. And remember that angles on the circle work just like inscribed angles. They're half the intercepted arc. So we have this 30-degree angle, and that's an inscribed angle that intercepts this arc right over here, which is the arc that angle PAT, the one in brown, intercepts. So remember, the arc is double the angle because the inscribed angle is half the intercepted arc. So if the inscribed angle is 30, this is 60. And so that means that the angle on the circle would be half of that, which is 30 degrees. And then finally, we just need angle T, which is this outside angle. And remember, the outside angle is half the difference of the intercepted arcs, big arc minus small arc. So outside angle is angle T. And then if we follow within the rays, I'm going to just outline this in purple of the angle. The small intercepted arc is 60 and the big intercepted arc is 160. So half of 160 minus 60. So 160 minus 60 is 100. Half of 100 is 50. So angle T is 50 degrees, and we're good to go with that one. And then one more for this video. I recommend that you do the same thing as the other two, that you try to draw the picture, you try your best, take a long time looking at it, and then when you're ready to see the solution, unpause it. In the accompanying diagram, PA is tangent to circle O at point A. Secant PBD intersects diameter AC at point E. That's good to know. So that means it splits the circle in half, 180 one way and 180 the other way. Chord AB is drawn. Angle P, so the outside angle, is 40 degrees. And the ratio of arc CD to arc DA is 1:8. So CD is the one part of the ratio, so I can represent it as 1x. And DA is the 8 part of the ratio, so I can represent that as 8x. And if I put the two parts together, the 1x and the 8x part, since AC is a diameter, it splits it into a semicircle. So that's 180 degrees. So I'm going to make an equation that says if I take the 1x part and I add it to the 8x part, I get 180 degrees. I have 9x is 180, so x is equal to 20. So this 1x part would just be 20. And this 8x part would be 20 times 8, which is 160 degrees. First, it's asking us to find the measurement of arc DA, which we just did. It was 160 degrees. Now it's asking us to find the measurement of arc AB. Arc AB is within the rays of outside angle P. It's the small intercepted arc. And we just found that the larger intercepted arc is 160. So remember, the outside angle is half big arc minus small arc. So angle P, the 40-degree angle, is the outside angle. And that's half of the big arc, which is 160, minus the small arc, which we're trying to find, which is x. I'm going to multiply both sides by 2 to get rid of the 1/2. So we have 80 is equal to 160 minus x. If I subtract 160 from both sides, I get negative 80 equals to negative x. And if I divide both sides by -1, I have 80 is equal to x. So this arc is 80 degrees. Now it's asking us to find the measurement of angle BEA. That is one of the vertical angles formed by intersecting chords. And I'm going to highlight those intersecting chords. And the intercepted arcs for those vertical angles are these two arcs over here. So we're doing angles inside the circle. So the vertical angle, the angles inside the circle, are half the sum of the intercepted arcs. When it's outside, it's half the difference. When it's inside, it's half the sum. So the vertical angle is half of 80 plus 20. And that would be 50 degrees for the vertical angles. Next, we're looking for the measurement of angle BAC. Angle BAC is an inscribed angle, so it's half of its intercepted arc. We just need to find its intercepted arc. We need to find BC. Luckily, we know that all the circle makes 360, and we have all the other pieces. We have the 80-degree arc, we have the 160-degree arc, and we have the 20-degree arc. That makes 260. So that means to make 360, the leftover one needs to be 100. So the inscribed angle is half the arc, so that would be 50 degrees as well. And finally, the measurement of angle PBA, that is this angle on the circle, which is half of its intercepted arc. The intercepted arc is 80, so the angle is 40. And there we have it.